Hi, hello and welcome. Today I will guide you through my latest plugin, LKplugin, which is a finite element calculation tool for 2D frame structures, which are connecting MatLab with Grasshopper, and I will show you that later. First, the installation of the plugin. You can follow the development of the plugin and find all the Python code on GitHub. I will link the address below. And in releases, you can find the zip file with the necessary Grasshopper user object files. So when opening this, you have the plugin, the folder, and if you go into Grasshopper, you can go to our user object folder, and this folder just simply needs to be dragged in here, and of course make sure that none of the files are blocked by Windows. So when it's installed, we should get this in the toolbar, these 7 components. We got 6 components defining the inputs for the MATLAB script, and 1 writing, running, and plotting the information from the MATLAB script. So let's take an example. We have this frame structure with these 5 elements, 5 meters long. We can start by defining the topology. Always use this in the beginning. It needs some input, so we connect this to here. And as you can see, the topology is plotted with the element 0, element 1, element 2, and so on. And node 1, node 0, node 1, node 2, node 3, and 4, and so on. We got a couple of inputs here. We can define whether it should sort the elements by its midpoint, or if it should sort the nodes of the elements by also by its coordinates. So we get a nice structure for our topology, and it's set as true by default, so we keep that. As you can see in the output, we got the nodes, which are in meters, because that's what the MATLAB script needs. And we got some other outputs that we are going to use for the next couple of components. So now when we have defined our topology, we can add a material to it. Also here we have some predefined values. We just keep them as you can see here, and it needs some element indexes, and we don't want to apply these materials to all our elements, so therefore I will make a list with this series with all our indices of our elements. Yes. That's just one way to do it. So this is our material matrix from MATLAB. It's shown down here. We'll connect that to the final component later. Then we can add some loads, for example, to element 1. So put in 1 in the element index, and then it needs some element planes. You see here, and a direction. We want to add we want to make it a vertical load, so we just keep this this direction vector, which is a set vector in reverse set vector. Here we can define the load size. We can say this by it's Newton per meter, so it's 2000, for example, which is approximately 200 kilos per meter. And then we have this global, which defines whether the direction is a global direction or if it's local to the element. So if we have put in element 0, a set vector would be perpendicular to the element. Again, we get this MATLAB matrix. And then we can define maybe another node load, maybe. Let's make it push the construction from here. So we need a x vector. So that's our direction. And we want to apply it to node 1. That's this one. And then it asks for some node doves. That's the one that are generated in here, which are the degrees of freedom for the construction. And the load size, we can use the same for this. And then we can make some supports. We can make it our construction cantilevered by locking all these through both in X, Y, and rotation. So it's set to that as by default. So we could take our node doves, which is asked for, and then we need our indices for our points, which should be locked. So it's 0, 3, and 5 in our case. It could be something else as well, of course. Oops. Yes, and we can add a hinge. I will show you that how to do that later, but first we can use this to make our calculation. So we take our MATLAB component here. So it asks for MATLAB nodes. That's just generated from the topology component as well as the elements. And because we're not adding any hinges in this part, then we have the same the degrees of freedom the topology component makes is makes it all makes it a stiff construction with no hinges in it. So if we want to add a hinge, we need to use this component. Then we take our MATLAB materials, the MATLAB supports. Oops. The MATLAB node loads and the MATLAB element loads, and then we have a plot scaling set to 40 and 0.002. Yes, we see how it looks. We add a button, and then we can try and push this. See if something happens. The first time always takes a little longer for MATLAB to start up, but as you can see now, we have our deformation plot. You can see it on the structure here. You can scale it in here if you want to make it more visible. And then run it again. This time we see MATLAB starts up, and it should close down. This again, and then we have. There's always some issues the first time we run it when it has to generate all these text files that it relies on for the plots. And that's one way to make this structure. We can now try and add a hinge, as I said. We can first we want to add a hinge to node 2, which all these elements uses. So we put in 2 and in this add hinge element, add hinge node. Oh, sorry. And then we take our node doves from here, and then ask for element start index and element index in end index. Then we get some new MATLAB doves, as you call it. We connect them to our MATLAB doves up here. Then we can try and run it again, and we will see that this angle is no longer 90 degrees. Again, we see MATLAB start up, closes down, and we see a much more wobbly construction because we add a hinge to this part. We can also just take a look at our moment plots, for example. We can see all our displacements not in scaled numbers, but our real displacements for all our degrees of freedoms. We can see our reaction forces, our normal forces, shear forces, and moment forces, and then we got all our plots. The formation plot is what's visible by default, and then we have our moment plot. You can connect that to this one. Let's turn this off. Here we can see, maybe we should scale it a little bit. Again. Here we can see our moment plots, and as you can see, we have no moments in this point, which makes sense because we add a hinge, and we of course have a larger moment in this bar because that's the only one we made element load on. You can see our normal plots on our shear plots. Let's try and add a hinge only to this element 3. So we have a stiff construction here, and then we have a hinged construction in this part. This means we put in this index for the hinge into this one. Simple as that. And then we run it again. And then we can look at our moment plots. Now we see we got now we got moments in this corner on this part of the construction, while there's no moment in this element. And we will also could see it in the deformation plot. Okay, it's not that visible, but this part is now hinged, so it is not keeping the angle to the rest of the construction. Let's try with another example. We can take just like this. This truss bridge. We have our curves here. Just turn it off so we can take our topology. And we get all our element numbers and index numbers. A truss usually have no hinges, maybe except the supports. Again, we make our material matrix. That's for all our elements. So we take list length. And a series, for example. Put it in here. And we have our MatLab material matrix. Then we can add a lot of loads. Again, we want to add it to all our elements. We want to put it on the dead load. To put this in as well. And our element planes. And we make sure this is global because we want to be the gravity that pulls it down, so it should be a global z direction vector. The load size we can put as 2000 again, maybe. So this is our element load. We're not going to put any node loads on it. Then we can take no hinges, so we take our supports. And we want to have a support at node 0 and node 8. Then we take our node doffs up from the topology. And this time we want it to be just simply supported, so we don't want it cantilevered, so we set this as false. Use a toggle. So it only logs the x and y movement. And yes, then we can take our MATLAB component here. We add our MATLAB nodes, our MATLAB elements, and because we don't need any hinges, we add our MATLAB doves as well, our material. Node load sets, if it's no node load, it by default sets it, as you can see, as BL equal, an empty matrix. So we don't need to input anything to that. We can also put the MATLAB support up here. Now we can see it reads the output file for the old construction, but that we will update when we run the component. So when we run it, you can see MATLAB start up, close down, and then we can see our deformation. Again, put a little more scaling to it so it's more visible. Run it again. Now we can see how it deforms and what our displacements are in meters, what our reaction forces, normal forces, shear forces, and everything. We can also look at our moment plot. And our normal plot. See larger normal forces in the middle in here. And a shear plot. So that's all I want to show you today. Feel free to comment below or come with any suggestions. It's still in an early beta state, so there's still some things that can be improved. Yes, thank you for watching.